Hello, friends. I'm going to discuss two formulas about backpropagation that were used in this very interesting book. I recommend everyone who wants to understand neural networks to read it. Okay, so regarding the convention of the book, well, for example, say we have multiple input neurons. Okay, this is, for example, the first layer of the the first layer, the first layer of actual neurons. So 1, 2, 3. Say we have up to neuron K, and then we have finally up to neuron, let's say M, and then we have another layer 1, 2, 3, etc. I don't know, K or J. Not sure what to say. K, L, M, N, F. I don't know what the letter. J. J. I think it's fine. But I may use J then here, whatever. Neuron N. And finally we have the output neurons. I don't know. It's according to our classification, how many classes we do have. So they are densely connected together. Now I'm committing with the convention of this book. I'm committing with the convention of this book. So say this is layer, and say we have multiple layers in between. Not here actually. Over here and over here. Whatever. Say this is L. In total, they are. This is layer of index L, for example. This is layer, can be index L minus 1, whatever. I don't know what to say. Let me say this is L and this is L plus 1. But I may finally use this index as L minus 1, capital L minus 1. So you have weights and biases, and each one has W, say 1, 1. Now this one is like W, it is from 1 to 2, so 2, 1, and this is weight, and 3, 1, that is from 1 to 3, and then this one, this is W 2 to 1, and this is W3 to 1. This is the convention of the book, and it's really useful, meaningful, and all these weights, for example, this one is W from N to K. Oh, sorry, from K to N, and the superscript is L plus 1, 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 is L plus 1. So the W matrix for this layer, there's all the weights that are coming to this layer. There are the weights that are affecting these neurons. So when you say W11, or this is one W, is from 2 N, the final one. I think it is like from 1 to N, I'm not sure. 1, no, this is from N to 1, so this is from M to 1. Yes. no, so M1. M1. It's from 1 to M. From 1 to M. So this is the convention. This is N1. From 1 to N. From 1 to N. And from M to N. And this is probably W from K to 1, from K to 1, from K to 1. Yes, this is the convention here. And this is omega or W from K to J, from 1 to J. Okay, so the rows represent the final neurons of the layer L+1, and columns represent the input neurons. Columns represent the neurons of the layer before. Okay, what a big deal. Not much really interested what you're saying now. Now I would like to comment on probably the final one. Assuming we have a okay. Again, in our book, we have this. I'm just assuming that all these weights that are coming from up to this particular neuron J. Let us say that this is our neuron J, and all these guys that are affecting J. I'm only interested about the previous neurons and this neuron J. So it is described in the book Z. This is Z, which is equal to A is the output of the output of 1 is A L1, and the output of 2, and this output here it is multiplied by W, and this same value is multiplied by W to 1, same value multiplied by W 3 1, etc. by W N1, okay, or W N1. Okay, now let me say here that the rows are neurons of next level, or of level L+1, and columns are neurons of level L, columns L, and rows are for L+1. Anyway, so this is Z for this, I don't know, let us call it L+1, and the J, it's actually the sum of, and this is the output of this neuron is AL2, ALK, sum K, ALK times W coming from K to J L+1 I hope I'm not mistaken. And don't forget the biases for each one, for each neuron here. It has one additional bias. You can say the value 1 here, and then you multiply it by a special weight called the bias B, BL, because it's coming from L, as if it is coming from L to 1 here, and then this one here, it has a special B, L, J. Okay, I think this is the convention used. So it's plus B, J, L. Okay. Okay. So this is the convention. This is symbolic, this semi-rectangle, because we apply to this value z, we apply the sigmoid function. So a sigmoid of z L plus 1 j is equal to A. It is the output of this neuron, which is a L plus 1 j. Okay. Now all this is a convention. This is not what I really wanted to discuss in this video. Let's check a little here. Neuron. Okay, and we have a cost function. This is ZLJLL minus 1. Omega BL. Oh, the L should be here in my case L plus 1, because, and even this is L, this is L. What have I made wrong? L plus 1, omega L plus 1, true, and BL L plus 1. Okay, so we want to call this BL plus 1. Okay, AL and WL plus 1, L plus 1. Okay, so we want to call this BL plus 1 and this BL plus 1. Okay, the same as WL plus 1, BL plus 1. So this is our formula, which is the same as this one. And this is AL, this is a vector, this is a vector. Sigma is just a function applied to a vector. This is a no, omega L is WL is a matrix, and it is multiplied by AL minus 1. So and plus BL. BL is a matrix as well. For example, this matrix BL is like BL. It's a column vector. BL1, BL2, BL3 up to BL. For example, in my case, up to BL plus 1 L, BL plus 1 1, BL plus 1 2, etc. up to. And what about the AKL? Okay, now okay, when you want to make a matrix, we put this term here. For example, it's like summation. I'm gonna do it for Z. I'm gonna keep it L plus 1 J. It's okay. So omega J from K to J, L plus 1 times A L K. Yeah, exactly. Suitable. They are suitable. Plus exactly, plus b j l plus 1. Okay, now this is a matrix. This is our matrix here, and this is our vector vector alk, al1, al2, and al superscript, and n, that is from n, no, m, because the length of this vector should be equal to the length of the, or to the, like to the width of the matrix. This is how we multiply it, and this is true, alm. Okay, and then multiply this one by this one plus this one by the second term plus the a lk by a1k. Yes, alk a1 ak to 1 يعني 1k, and multiply a1m by alm, and that is absolutely true. So this can be written the same as this one, or that, yeah, it's okay. This is all just a convention. I'm gonna stop this video here as a convention for the convention used for the book. This is a wonderful guy. Okay, bye bye. I'm gonna in the next video I'm gonna explore this first two formulae, formula about of backpropagation, and I think we are going to start with this one. Finally, I would just want to say that in our case, for example, for simplicity, we have just two output neurons, and yes, they are connected densely. So we have, of course, a Z capital L J capital L1. We have Z capital L1, Z capital L2, and okay, and we can still apply sigma to these two values, so we can obtain AL1 and AL2. And say we have a desired value called, for example, y1, y2. These are the desired values, not the obtained values. And so the cost function is something like sigma al1 minus y1 square plus we can do here, put here j whatever, but they are only it's 1 plus without the sigma al j minus y2, I'm sorry, 2 square. So it's a summation of these two. If you want to normalize, I don't know, you can divide by half. We can check it if you like. And this is our cost function, which should be minimized, and we try to minimize it till with the intent to yes, it's divided by 2 because we just want to normalize it. It's not a big deal actually, the divide by 2. It's not a big deal. Okay, and actually this is Cx. What do you mean by x? X is the input. X is the input here, and y are the desired outputs corresponding to these x's. So this can be for a particular x, because for a particular x we have a particular values of y. Now we can extend this a little for multiple attempts in solving. For example, Cx, for the first x's, the first ones. X1 corresponds a vector, for example, to all these. This is my convention. Plus C, let us call it just C1, C2, plus C3. Yeah, okay. C1 for the first x's and the first y's. C2 for the second x's and second y's. C3 for the third x's and third y's, etc. And we can all divide by the number of inputs. I don't know if this can be called batch or mini batch in our attempt to optimize the values of the weights and biases. So our all interest is really on minimizing or finding the best values for the weights and biases. So we can divide by the number of inputs. You can divide by the number of inputs, and we will obtain, yes, this is divided by n. Here he called it n, but it's not a problem. N is like number of samples, for example, but the samples for a batch, not the whole samples, I guess. Batch or mini batch. And if n equals to 1, then this is like a stochastic gradient, probably something like that. Now enough for this video. In the next one I'm gonna discuss I'm gonna discuss here only the first two equations of the four equations about behind backpropagation. Okay, bye.